The next segment inside of a triangle that we want to discuss is called the altitude. The altitude of the triangle is a segment that goes from a vertex that is perpendicular to the opposite side. And don't get that confused with the perpendicular bisector of the side. The perpendicular bisector of the side went through the midpoint of the side and may or may not go through the opposite vertex. But the altitude starts at the vertex and is always perpendicular to the side, and it may not go through the midpoint of the side. Let's take a look at what an altitude in a triangle looks like. And we'll notice here that there's a little caveat that says perhaps extended. Let's take a look at why it says that. If I wanted to construct an altitude of triangle ABC, let's say I want to start with vertex C. I want a segment that starts at vertex C and it needs to come down to segment AB, and it has to be perpendicular to segment AB. I'm going to choose my perpendicular line tool, and I'm going to choose the line that I want it to be perpendicular to, which is line AB, and then I'm going to choose the point that I want it to go through, which is point C. And so here is a line that is perpendicular to AB that goes through point C. Now I want the point where that intersects segment AB. And so segment CD is the segment that is the altitude of the triangle. Now, the reason that we say that it may have to be an extended side is this. In this case, we have an acute triangle, and the altitude fits nice neatly inside the triangle. But notice, so start moving point B. If point B starts getting closer to being a right angle, this altitude eventually, when point B is right here, where point B is a right angle and triangle ABC is a right triangle, then the altitude actually is this side. Point B is kind of hiding under there under point D, but it's really the same point. And so CD is a side of the right triangle, and it's also an altitude of the triangle because it is perpendicular to the other side. Now, when I make angle B actually be an obtuse angle, so this angle B is now larger than 90, it's impossible to have a line that starts at point C that is perpendicular to segment AB. This perpendicular won't hit it. And so what I have to do in order to discuss having an altitude is I have to extend segment AB out further with this ray. So now I can talk about the altitude of the triangle, and the altitude of the triangle is the segment CE, which is actually on the outside of this triangle. So you have to take the line segment of the triangle and extend it out, and then come from the vertex opposite that side and come straight down to the extension. And so here's my right angle here. So the altitude may be on the outside of a triangle. In the case of an obtuse triangle, it turns out that two of the altitudes actually fall on the outside. Now, we can draw all three of these altitudes. So now triangle ABC has all three of its altitudes drawn. And so segment AD is an altitude to side BC. So AD is perpendicular to BC, or perhaps the extension of BC. And you can see I've extended these sides, all the sides out in both directions, so that I can continue to have an altitude even when the triangle becomes obtuse. And they all meet at this point G right here, which has a special name that we'll talk about in just a second. So notice though that meeting point could be on the inside of the triangle. If the triangle is a right triangle, as it is now, they will meet actually at the right angle, and it could be that they meet on the outside of the triangle. So if you extended this on down, if you extended all three of these altitudes on down, they don't meet inside the triangle, but they would all meet down here at this point G down here. And so that point G is the intersection of the altitudes and maybe having to extend those altitudes out. So the altitudes either meet on the inside, or when the triangle's obtuse, they meet on the outside. Notice that when the triangle's obtuse, that two of the altitudes actually fall on the outside of the triangle, while one of them is still on the inside. You'll always have at least one altitude on the inside. If you have, or you could have two altitudes on the outside or all three on the inside. That's the two possibilities you could have. Okay, so what do we know about this special point here that's labeled G? The special point is referred to as the OrthoCenter. The orthocenter is the intersection point of the three altitudes of the triangle. And this triangle, point D in this example, is the orthocenter. We have the three altitudes. You can see they're meeting the sides at right angles, and they all three meet at point D. So that D is called the orthocenter. The orthocenter lies on the inside of a triangle if it's acute. It lies on the vertex of the right angle in a right triangle, and it lies on the exterior of the triangle in an obtuse triangle. So once again, the altitude is a segment from a vertex that is perpendicular to the opposite side, and the three altitudes intersect to form the orthocenter of the triangle.